Well, ahoy there, mateys. We are jumping right into 3.1. Welcome. So first, we're going to try and figure out what operations these problems are solving right here. So a little refresher on the operations. So if you buy 2 scarves for $15 each, how much do you spend? What operation would you be doing to solve this? You would be multiplying. So for that one, it is 2 times 15, which is $30. Okay, for the second one, it takes you 15 minutes to bike 5 miles. How long does it take you to bike 1 mile? What operation would we first need to do to be able to solve this? So the first thing you want to do is divide. So 15 minutes divided by 5 miles would tell you it's 3 minutes per mile. Okay, for the third one, 4 friends split a lunch bill that costs $24. How much does each person spend? Again, what operation would we be doing on this problem? So it's $24 divided by 4 people is $6 per person. So that is a division problem. And the last one, you traveled 70 miles of a 200-mile trip. How much further do you have left to travel? So what operation would you have to do to solve this one? So for this one, you would subtract 70 from 200, and that tells you there's still 130 miles to go. So part of what we're going to be doing with this unit is first identifying what operations are being done. However, sometimes we are going to be missing numbers. So we won't actually be using numbers. We'll be using letters. And that is basically what algebra is. So we're going to be doing expressions. And an algebraic expression is basically a number sentence that does not have an equal sign. If it has an equal sign, then it's an algebraic equation. So an algebraic expression is basically just a number sentence, and it has terms. So the one that they have here on the screen, this 5p plus 4, has 2 terms. One of the terms is 5p. The other term is 4. So terms are basically separated by plus and minus signs. Now this 4 is a constant. It does not change. It's just 4. The 5 next to p means 5 times p. So whenever you have a number next to a letter, it means to multiply. The letter, instead of calling it a letter, we call it a variable. And it could be a bunch of different things. That's why it can vary, so we call it a variable. So the letter represents the possibility of putting many different numbers in there. So P doesn't stand for a specific number. P can change. And then the 5 that P is being multiplied by is the coefficient. So anytime you're multiplying by a letter, by a variable, that number is called a coefficient. So now's a good time to take some notes on this stuff. These are very important words we're going to be using a lot, not only this year, but for the rest of your math career. Okay, so now we're going to do some examples. So for this one right here, 5x plus 13, what is the variable here in 5x plus 13? It is 13. And what is the variable? The variable is x. And what is the coefficient? The coefficient is 5. So here we go. So it has 2 different terms. It has 5x as one term, 13 is the other term. The coefficient is only 5. 13 is a constant because it's all by itself. Nicely done. All right, now for b, how many terms are there for b? There are 3 terms. And then here's a trick question. What is the coefficient next to y? All right, this one you might not have known. So anytime you have a letter by itself or a variable by itself, there's an invisible 1 here. So this is plus 1y. The coefficient for y is actually 1. And what's the constants in this number sentence, this expression? There's only one constant, and it's 3. 3 is by itself. So here we have 3 different terms. We have 2 coefficients. The one next to z squared is 2. And the one next to y is 1, even though it's invisible. And there's only one constant of 3. And then there's also this 2 right here. This is an exponent, so don't forget about exponents. So, and that leads us to our next example. Boom. So you're going to write these expressions using exponents. So if you have d times d times d times d, how would you write that using exponents? It is d to the 4th. There we go. Okay, what about 1.5 times h times h times h? So you just put the 1.5 in front with h to the 3rd afterwards. You don't need the multiplication symbol or a time sign. You just put the the coefficient right next to the variable. So 1.5 h cubed. All right, and then sometimes you'll be evaluating. So basically what that means is you're going to substitute in the number that they tell you to substitute in for the variable, and then evaluate it, see what you get. So evaluate k plus 10 when k equals 25. All right, so you're going to plug in 25 for k. You just substitute 25 here. 25 plus 10 is 35. There we go. Easy peasy. All right, evaluate 4n, or 4 times n, when n equals 12. So you got 4 times 12, which is 48. Okay, so you'll be doing some evaluating. And sometimes you're going to have to substitute 2 numbers. It's the same deal, though. So evaluate a divided by b when a equals 16 and b equals 2 thirds. You may want some scratch paper. Okay, so first you want to rewrite it. So a divided by b, you put 16 for a, you put 2 thirds for b, so it's now 16 divided by 2 thirds. Now, of course, you remember how to divide fractions. You take the second fraction here and you flip it, you find the reciprocal, which is 3/2, and then you multiply. It becomes a multiplication problem. A lot of times you're going to start seeing this dot more and more often for multiplication because we're going to start using x as a variable. So you don't want to confuse x's and time signs. Now you can write 16 over 1 and multiply, you get 48 over 2, or simplify it to 24. Okay. And we got a couple more examples. So evaluate 3x minus 14 when x equals 5. Okay, common mistake is people will write 35. This does not mean put a 5 here and call it 35. This means 3 times x. So again, anytime a number is next to a letter, it's multiply. So it's 3 times 5 minus 14. So it's 15 minus 14, which is 1. All right, now evaluate z squared plus 8.5 when z equals 2. Okay, so first, again, you substitute, put the 2 in for z. 2 squared plus 8.5. You got to do 2 squared. 2 times 2 is 4, plus 8.5 is 12.5. Okay, and our last example, actually, before I get to that, you're going to encounter another thing on your homework, on your big ideas. I'm going to throw it out here before I forget. Sometimes you're going to have like x over 5, bam, and it's going to want to know what's the coefficient. So in this case, the coefficient is not 5. The coefficient is actually 1/5. So anytime you have a variable on top of a number, that's the same as like 1/5 times that variable. So the coefficient here is like 1/5. So again, one more example of that. If I have, we'll make it even trickier. 2m cubed over 5. My coefficient is actually 2/5. Okay, so the coefficient here is 2/5, and then m cubed is my variable. Okay, so you're going to have this sometimes also, just throwing it out there right now. If you have questions about this, ask me. Send me an email. Ask me in class. Okay, now this last one we're going to go over. So you're saving money to buy a skateboard. You begin with $45 and you save $3 a week. Your expression is 45 plus 3w. That's the amount of money you have after any number of weeks, w. Okay, and it says how much do you have after 4 weeks and 10 weeks and 20 weeks? So right now I want you to figure out how much would you have after 4 weeks? All right, so that might have taken you a little bit of time. You might have plugged in. You might have done this different ways. What I would suggest and what they suggest is you actually make a little table, and a way to organize your data. Okay, so you would write out the weeks that you're looking for, which is 4 and 10 and 20 in this problem right here. And then we have our expression, which is 45 plus 3 times w. Now, a lot of you figured out, well, I have to do 4 times 3 because it's 4 weeks, $3 a week, and then add the 45 that I already saved. So it's $57 that you'd have after 4 weeks. Okay, now if you make a little table, you can also organize for 10 weeks, which they ask you about, and for 20 weeks, which they ask you about. Bam. So now that we have our table, it shows you the amount you have saved. And then the question is, after 20 weeks, can you buy the skateboard? And here is the price of the skateboard. So no, you can't buy the skateboard because you only have $105 and the skateboard's $125. All right, so you will have a couple of word problems, but most of it is going to be straightforward. Identifying coefficients, exponents, variables, how many terms there are, things like that. Let me know if you have any questions. I'll be available through email as well if we're not currently in class. And you can also check with Ms. Rude through the ASC link, or you can ask me a question on Flipgrid. So good luck working on 3.1, and I will see you in class next time. All right.